In today's video, I will be explaining the problem shaping regions. So here we have a few rectangles with different colors, and some of the rectangles may overlap the other ones, and we're asked to find the total area that shows for each of the rectangle. So this problem is very similar to window area in chapter 5. And this problem is actually even more simple than that one, because here all we have to do is calculate the area. And so whenever we have one rectangle overlapping another one, we can think of splitting this rectangle into the parts that are not overlapped and then calculate those areas. So this is what we will do here. First of all, I'll create this structure to keep track of the rectangles. This x1 and y1 will be the lower left corner, and then x2 and y2 will be the top right corner. And the c will keep track of the color. And also here I made this area function to get the area when we need to. And so first, after we reading out the input, I will also create another rectangle, and that rectangle is basically the paper itself. And the paper itself basically has the bottom left corner at 0, 0, and the top right corner at AB. And this should have a color of 1. Then we look at all of the So here we look at all of the rectangles that we have and calculate the area for each of those colors. And when we're using this calculate area function, this will first get all the rectangles that overlap with this current rectangle that we're looking at. And since we are only looking at the area that's overlapped by other rectangles for this current rectangle, all we need is just the area inside this current rectangle. So we should get the maximum x1 for these two overlapped rectangles, because this way we will make sure that the biggest rectangle will still be in the range of our current rectangle. So this is the same for the x1 and y1. Then we get the minimum for x2 and y2, because this way we can make sure that it's small enough so that it fits inside this current rectangle. And then we push these coordinates into a temporary vector of rectangles, and also we keep the color of this current rectangle, but we can use any color here because the color for these other overlapping rectangles don't really matter. And so first I will get the total area of our current rectangle, and I will subtract all the overlapped areas from this current area. And so for each of these overlapped rectangles, I'll use this get area function to get the overlapped area. And to do that, we will first reading a rectangle and also the position of this rectangle inside the vector. And we do this because this way we can increase our position, so next time we can find another rectangle that overlaps with this current one. So this current rectangle is actually one that's overlapping our rectangle at this index. And we want to subtract the area of this current rectangle that overlaps it. But there may also be other rectangles overlapping this current rectangle, and if we subtract all of those areas, we're going to take away multiple areas that's overlapped. So we have to make sure that we don't take away the overlapped areas multiple times. And we should look at a few special cases when we have overlapped rectangles. So we increase our position until inside this. So we increase our position inside this vector until we reach a rectangle that overlaps with this current overlapping rectangle. And to use the overlap function, I just made it here. So basically, we're comparing the leftmost coordinate for the first rectangle with the rightmost coordinate for the second one. If the leftmost coordinate for the first rectangle is greater than or equal to the second for the rightmost coordinate for the second one, this means that this first rectangle is completely on the right side of this second rectangle, so they don't overlap. And this is the same the other way around. When we have the x1 for the second rectangle is greater than or equal to the x2 for the first rectangle. And this is also the same for y1 and y2. So these are the cases when these two rectangles don't overlap, then we will return false. Otherwise, they will definitely overlap somewhere, so we'll return true. And so every time we'll check for that overlap, so we find another rectangle that overlaps the current overlapping rectangle. And then, of course, there's this other case if our positions already reached the end of this vector. This means that there are no other rectangles that overlap this current one. Then we should just return the area of this current one because all of that area is overlapping our main rectangle. And otherwise, we should look at the areas that aren't overlapped by any other rectangles, because for those areas that are overlapped by other rectangles, we would calculate them later on using the same function as well. And here I'll use this total area to keep track of the actual area that's covering the, our main rectangle without being overlapped by other rectangles. And so there are a few cases we can look at them in an example. So let's think of this as the rectangle that overlaps our main rectangle. And this rectangle could be anywhere. We can say if this rectangle was over here. Then if this rectangle is over here, we should exclude the area for this part. And to do that, all we have to do is basically calculate the area for this top part only, and also only calculate the area for this part on the right. But here we have to note that these two parts should not be overlapped, because this part is already calculating one of the rectangles, so we don't want to overlap this area over here. And to do that, every time we will basically decrease the y coordinate, or we'll basically change the y coordinate or change the x coordinate. So every time we can modify the remaining area that's that's not overlapped by other rectangles. So then we will still be able to sum up the rest of the area. And so to do that, there are a few cases. The first case is if the current rectangle that overlaps this overlapping rectangle, if this x1 is greater than the x1 for our current overlapping rectangle, this means that the rectangle that we're looking at is so this rectangle that overlaps the overlapping rectangle is to the right side of our current overlapping rectangle. And so we can think of that as the case when we basically have one rectangle over here, let's say to the, at this part, because this way it's on the right side of our main rectangle. But actually, let's think of this as one rectangle that overlaps this rectangle. And this rectangle, we shouldn't think of this as the main rectangle. We think of this as another rectangle that's overlapping the main rectangle. We can, let's say we can make our main rectangle this at this position. So we can think of this one on the back to be the main rectangle. And this one is just another rectangle that overlaps the main rectangle. And then this green rectangle here will be overlapping the overlapping rectangle. And we should take away the area from these positions, because next time we would calculate these areas from our green rectangle using the same get area function. And so when we have a case when this green rectangle is on the right side of this overlapping rectangle, we should get the area for this side. So basically this place. And to do this, we can basically think of the x and y coordinates being still the same, but here we change the rightmost coordinate for this overlapping rectangle to be at this right coordinate. So basically, we change the x2 for our overlapping main rectangle, and we change it into x1 for this green rectangle, because here we are only looking at this place. So this position is basically at, so now our new x2 is at the x1 for this green rectangle. And so this is what we do here. We change the new x2 to the to the x1 for the other rectangle that overlaps it. And then we again get the overlapping area for that rectangle, but here increase the position by 1 again. So here we are making sure that we don't have any overlaps. And then after that, we would have already searched through this area, so we don't have to search through this again. We can now basically think of this as that side being already searched through. So now all we had to look at is just this top part. And so then we will do the comparison again, but at comparing different x and y's. So this is the first case when we're comparing the x1, and the second case is when we're comparing x2. So when we're comparing x2, we can think of it as finding a case if there's another rectangle on this side, and it's so basically we can erase these points, and we can think of this rectangle as being on the left side now. And when it's on the left side, the x2 for this green rectangle should be less than the x2 for this bigger rectangle. So if it's the x2 is smaller than the x2 for this current rectangle, then we still do the same thing. But here we're looking at just this area. So we're looking at this side, and here the y2, y1, and x2 remain the same, but here we move our x1. So x1 at first was at this place, and now we moved it to this place. And x1 at this place now is basically the same as the x2 for the green rectangle. So we change our x1 to the x2 for this overlapping rectangle. And this is what we did here. Change the x2 into this overlapping one, and also get the overlapping area for that rectangle again, so we will prevent ourselves from finding multiple overlaps. Also with p+1, and then here we also update our area for this current rectangle. Since we've searched everything from this side, we won't need this anymore. We won't need this whole area anymore. So now we can basically change our x2 to this place. So now we're changing our x2 to the x2 for our green rectangle. And so this is what we did here. Change the x2, so then we shrink this rectangle. Now we just have to look at the remaining areas. And this is also the same for for y1 and y2. Here, when the y1 for the overlapping rectangle is greater than the y1 for this current rectangle, this basically means that it's on top of it's on this area on the bottom part of this rectangle here that's not covered up by this current rectangle that overlaps it. So we should look at the area at this bottom place, and it's all the same, changing to different y1 coordinates. Also getting the area again and adding it to our total overlapping area, and then also resizing our main overlapping rectangle to this y1, and this is also the same for y2, but this is the case if there's some area on the top part of this current rectangle that's not covered up. And then finally, after we've added up all the areas, we will return this total area that's covering our current rectangle. So we'll get that, and here we should subtract that area from this overall area because these areas are covered up. And finally, we will just add this total area that's still showing to our color, to whatever this color this rectangle has. So add that, and we do that for each one of these rectangles. And here, this rectangle 0 will represent the main paper. So here we still do the same thing, basically find everything that overlaps this main paper, and then also calculate the area for that. Then we loop through all of the colors that we have. So here I said that the maximum color is 2500, so we will loop all the way there, starting at 1 to 2500. And so we don't need to print out the colors that aren't showing. So if we will print these out only if there's at least one unit of this color showing on the paper. Then we will print out what color this is, and then the total area of this color that is showing.